I'll be presenting about this very interesting subject for me of how your mobile network security is being bypassed, it's being circumvented by some malefactors. So first thing, where do I speak from? I've been working in mobile last 20 years or so, half of this time in mobile operators, other half in security providers and telco equipment providers. So what I know is that there are security bypasses. So this is the base diagram I'll be using. So usually you're connected to international roaming, to IPX on the left. And then there are two types of messages that should come. Good message, the blue ones, they should just go through it, go to your border element, maybe STP, DEA, and pass through the firewall and enter your network because they are useful for roaming. And the bad ones, they should be like the yellow, they stop at the firewall, and the firewall reports what it has done. Okay, I have this amount of messages have passed, and this specific message has been blocked. Unfortunately, there's a third kind of message that is just the message that bypass your protections. So I cannot blame the firewall for everything. Sometimes the bypass is at the border. So let's say your STP is misconfigured or is configured in a way that not every message is routed through the firewall. And some messages just go across it because of these elements. Maybe you just did a software upgrade. Maybe you have some 5 years wholesale configuration, 10 years wholesale configuration you created. No one knows about it. The guy that has done the project has left the company last year, something like this, and is still for part of the message. They don't go through the firewall. They go straight to internal elements. So this is technically the bypass. But the bypass is not only, let's say, to blame on the border elements. Sometimes your partner, your IPX provider, they do a configuration, usually to improve roaming address. Let's say, oh, I was accepting those bad messages. I was accepting these kind of addressing. Let's just translate all the addressing. So they do something to increase, to improve. But when they do so, they impact your chain of security inside. So they impact your either a border element or your firewall. You cannot tell which one will be impacted. But they change something here, change a parameter, do a translation, and then they screw up the internal routing. They just make it confused. They create a possibility that some message, and sometimes all the message, will bypass your chain and go straight to your core elements. Why this happens? So this is a 4-dimensional chess. Sorry to use this Star Trek. Okay, blame on me. But this is because those tables over here, they're not linear tables, right? I've been working a few years, as I told you, in the mobile operators. And I've been sometimes, and for some time, I was responsible for number analysis, like trees on the mobile switching center, where you say, oh, this call is international, it has a 00. I send it to international gateway, it has a single 0, maybe it's national, etc. This was the easy part. The problem is all this routing table. This is one dimension. When you go and you set for prepaid, the analysis change. Depending on the origin of the call, the analysis also passing through other table before getting into this routing table. So it's not something you can just look and analyze. It has multiple layers. And that's why it becomes very complex as a chain. And this kind of bypass is not uncommon. Let's type of bypass. Sometimes IPX changed nothing or impacted nothing. Border element is okay, no problem. Node has to send the message through the firewall. Still, the message goes through the firewall, but it's not analyzed. It bypassed the firewall itself. This is the most the focus of this webinar. The messages that are routed to the firewall, but somehow are not blocked. Somehow they, let's say, go through it as a regular message. They look blue for the firewall. So this is usually not a basic message, not a failure of service or anything, or misconfiguration. Those are very specifically crafted messages created to allow this bypass, right? This is not something that happens by chance. So one of these techniques is what you call varied length XUDT message segmentation. So let's go a little bit into it. When you have several messages from an intruder, the firewall will recognize those messages, and you block the messages that are not allowed into the network. But sometimes some data structures that were built and created to improve technology, they can be abused. So XUDT, or extended unit data, is an SSCP message type that allows for message segmentation. So let's say you have some limitations on your transmission, etc. This is very old times, right? You need to think this used to be all serial links. So sometimes you go, let's say, into subsea cables, etc. You need to split things on smaller segments, this kind of thing. This was when the first guy thought about this, they say, okay, I need ways of breaking a payload. So when you define a maximum length of the package, and your payload is bigger than that, it means this red part has to be transmitted on separate, independent segments. So it's just a way to segment one single message in 2 or more. Nothing wrong with that. The problem is your firewall uses all those layers to identify dangerous messages. Goes to SCP layer to say, okay, origin, destination, all good. Then goes to dialog, and then goes to component to see which operation is that, which is the opcode, right? So when it gets this information, it may finally take a decision. But when you segment these, you keep dialog portion intact, but you break, especially sometimes opcode from parameters. Sometimes you break it even more, and this segmentation can make your firewall useless, can just be impossible to be evaluated. Maybe even if you segment more, have 3, 4 segments, every 2 has a limitation. So what attackers identified is that it's possible to tweak this parameter, to change and test with various sizing of segmentation in order to bypass some firewalls. So as a single segment does not contain all data, what would the firewall do? Would it allow it, the first segment? Because if it allows the first segment, it must allow the remaining ones. Otherwise, it's sending half a message. So it's a decision that must be taken in short time, and sometimes for the sake of service, it will be taken allowing that message to go through. When this has been published, XUDT bypass was published first time in 2018. So 2 years afterwards, most of firewall vendors would say they support XUDT segmentation. But 3 years after that, also intruders have adapted this method, managed to find ways to still use XUDT segmentation. So we still see networks that are vulnerable to this attack, yes. Until the present days, we still see and test networks and prove they're vulnerable and help them increase on their security. Okay, so how does the attack works? Instead of sending out the info, single message, and the firewall would analyze and block, we split it into segments. So the attacker would use XUDT segmentation and have the send route info sent through into segments. Okay, this was blocked. The message was not accepted. I cut it in 40 byte segments, didn't work. This is valid information for the attacker. So they may change it in 2 segments. And this time, the segmented message was accepted. And for these VLR, no problem. No issue on handling segments. Has no judge of the merit of the message. The HLR will just send the response. So once it's accepted, it will be reassembled, and the response will be sent. So the attack was successful just by segmenting the original message. You see, the message will be split in bigger size, bigger chunks. Instead of 40, 45, you can tweak this as much as you want. And then you finally get a response. You get a response for sending out the info. And you get to learn IMSI, you get to learn sometimes subscriber location and all that was being concealed from attackers before. A second method, which is also used nowadays, is parameter tag manipulation. Those are methods used for SS7. I forgot to mention the 2 methods we're presenting today. Usually, we're talking now of the payload. So it's this parameter tag is inside the message. It's part of the message after the opcode, so it's not breaking the message in any way. It's not affecting SCCP layer, but inside the message there's one parameter tag. It was built there to press some parameters. As every of these fields, it has a range of documented and useful values that can be used. What if I just put a bad value inside? If you recall what we started when I started telling you, all these decision tables in every element, they are basically consider some standard parameters. So sometimes it's not on the firewall rule. Sometimes it's not described anywhere. It's just a global parameter, and it's hard. It's, let's say, encoded just on the code. They will analyze and they consider that correct message have correct parameter tags. If I put an unrecognized value, an unsupported value out of any specification, these may be enough to bypass your firewall. So everything else inside it will not be considered, will not be evaluated, because the firewall will say, oh, bad message, or cannot decode. And by default, sometimes they will send the message forward. They said, okay, I cannot decode, what should I do? Impact roaming or let it pass? It's also some global parameter over there, say, oh, let it pass, don't impact roaming, log for me. So it will create a log, which usually no one's looking at, because it's a fail log, error log, parsing log. We all know that parsing logs are not that usually useful. So they will remain there for years until someone looks at it. But meanwhile, when the attackers are sending this manipulated parameter tag, and the firewall is looking for the standard value, or the one inside the standard range, it will pass through. MSC VLR doesn't care about this tag. MSC VLR is telecom equipment. Telecom equipment will do everything possible to accept and process a message. They are built to it. That's the entire reason they are built to. These and billing. Those are the 2 reasons. If a telco equipment can accept and process a message and generate a CDR, they're totally happy with their functioning. Everything else, oh, this is out of scope, this is out of specification, not really 3GPP, I don't care. I will ignore it and I will do my job. So the VLR will answer with the cell ID of the subscriber. So just by change a small parameter, the attackers bypassed all rules based that are affected by this parameter that can use this parameter. This is also something. When you do this, XUDT, or you use a parameter tag for one opcode, is not limited to that opcode. This is a bypass technique. When it works for sending out info, for PSI, for any anytime interrogation, any operation you request will work also using this bypass technique. This bypass technique's generic one. It doesn't really rely on the message type. It's not that, oh, this will open just for location breach. No, it will allow for anything: IMSI breaches, location, SMS interception, anything you can do for provide subscriber info. In this example, if the firewall is vulnerable for this parameter tag, it can be used and applied to other messages. So again, this is one real recollection of an attack, so that's why it has something redacted. This is the manipulated tag. So map starts here. You change the tag to 31. You look at Wireshark, it say, oh, unexpected construction, cannot decode from here, blah, blah, blah. So Wireshark is not decoding. Your fire is not decoding. Your VLR doesn't care. It just ignores it and say, oh, what if it was standard value? I'm not even reading it. It will read the remaining bytes, see the opcode, and send a response. That's how those two bypass work. So how come we got into this point, right? That we have these gaps built. Several possibilities. First one is misconfiguration. So what if just some routing misconfiguration at the border, as the FTP, DA, the array? So sometimes these configurations require some specific tags, etc. You can just abuse them. Weak encryption settings, or your firewall rules are too complex, became too unmanageable at some point. So routing misconfiguration is easy. You send a message, depending on some parameter, STPDA will not send it to the firewall, and you go across. The complexity is somehow different. I'm using IT examples because they are, let's say, most common. But usually when you have access lists, when you have firewall rules, you have several parameters, and you have several rules on the list. So in order to understand how specific message, how specific packet will be dealt with, you need to read all those. You need to have all these on your mind. And sometimes it's multi-layered. So it's not only this rule, but there's a pre-processing rule, a post-processing rule, whatever. This becomes too complex. That's why we are not to be entrusted with complex tasks, right? When it's too much, maybe one expert, two experts in the mobile operators, they can understand and can imagine, they can do this tracing on their minds. Other than that, people are starting changing rules without knowing the final impacts. Other than misconfiguration, you can just be lacking security control. So you have different levels of security on different domains. You have not implemented encryptions at all, and you don't have monitoring. So when you don't have these kind of controls, you miss ways of identifying a bypass. And this is all observed also when you don't have a process, a closed loop process. You don't have visibility of what attacks are being successful. So you don't have, and you don't test, so you don't have the potential vulnerabilities, what's being exposed by your network. You cannot see the bypass because you don't have the process. Process can be not only monitoring. Okay, I want to know if it's possible to bypass. I can test, I can do a pen test, security assessment from the outside, and try to bypass my firewall. These will be part of a cybersecurity process. This is not a single firewall trying to handle everything on itself. So you don't have any motivations to update your configuration. You have no inputs. You just believe it's working. And you have no coordination between different teams. So there is one team, this is security teams. It acts independently. And of course, there's another team with the roaming guys that every week will be updating STPs, DAs, and other elements on the network. And Even sometimes they configure the firewall if there's an expansion. So let's say every week you receive a notification from 1 to 10 roaming partners saying that they have added elements or IP ranges, global titles to their roaming configuration. Usually you have 5 business days to reflect this configuration, otherwise you may be affected. So let's say Mexico sends me an update, they send me, oh, I'll be using these 2-3 new elements. I need to put them in my configuration. I need to allow them to interwork with my operator. Otherwise, my customers, when they go to Mexico, they can let's say they can lose service. They can face some roaming issues while they are in the coverage of these, in the areas covered by these new elements, right? So no one wants that. No one wants their VIPs without service, even to complain. But of course, cybersecurity process must be in place to avoid that. Unlike NIST framework, I pass just very fast through it. Most important thing is that it's not only about testing and implementing the firewall. Any framework, NIST is one of them. You say, oh, we must have monitoring, and you must have governance. So if you don't have the process and you don't have means to validate your protection by identifying or detecting real attackers, you're not doing a full job on security. So, okay, you can do benchmarking, you can do compliance tests. It's good, not enough. If you do a security audit, it's much better than just reading file reports and trying to guess if someone is getting across your protection. But again, you must do security. So I'm not talking against firewalls, not talking against any solutions. I'm just saying, see the whole picture, identify, monitor what you're doing. Don't only trust that filtering on the border or a firewall or any element will single-handed manage your security. So what we offer, of course, as Security Gen, we must offer something. We offer monitoring through our Telecom Security Guard IDS. So IDS can identify threats and successful attacks to your network, can provide you with not only the operations, but source, destinations, time of the attack has happened, the IDs of the message. So you have everything to identify on other element logs, why did this message went through, when it happens, why it went to the border element, why it has gone across the firewall, or if it hasn't gone across the firewall. So this is the power of the monitoring, right? So IDS is there to show you. I have some questions, so I start addressing some questions because I need to appreciate. Thank you so much. I'm talking about SS7 bypass, and I have some questions about diameter, GTP, PFCP bypass. Yes, bypass techniques are also available for those protocols. For diameter is, let's say, is more relatable to SS7. For GTP, sometimes you don't need a very, let's say, specific bypass technique. Why so? Because there is no authentication, not strong authentication from origin and destination. So yes, there are bypass techniques, but sometimes they don't even tamper with the packets. Sometimes you just do this by guessing tunnel IDs, for instance, or by brute forcing some IDs, as you don't need to be authenticated, as you don't want to be identified by the destination network. So you just try in order to get some real tunnels, some real sessions, and these kind of things. So afterwards, you can identify and use this learned information to do the bypass. It's a little bit different. So we have other questions I will be addressing in the coming slides. So one question is, where is this the source of the data I'm presenting? So the results were in part from our experts, in part from other telco experts, but everyone is concentrated. So if you look at first, it's Mitri's initiative for telco. You see, this is just one table. They cover 144 methods for telco networks. We covered on IDS 83 on our products indeed. Some additional require verification, and some of those methods described are rather academical. So yes, the risk is there, but we don't find it in any commercial implementation. So this is where this information comes. So we did our research, we learn from other researchers, and we expand the research. So we go the next step, and then we implement these on our techniques and on our products. So again, we also contribute to this. We are not only, let's say, freeloading on published material. We are also proposing methods, proposing techniques, tactics to Mitre, and they sometimes have been reflected there. Another, you asked me about GTP, so that's why I asked it some time to go to some additional slides. For instance, GTP door, not our research, but it was published. So they established that some elements have been compromised, and they could later be assessed and controlled by using some GTP package. We implemented signature on IDS to detect those. So that's why I tell you about monitoring this, because this is not, let's say, really ideally to be blocked in a GTP file, right? Because you don't know when it will come, which kind of message, etc. But it can be monitored in order to learn if you have a compromised element. Of course, we have the signature for the firewall as well. But the main thing is that when you have any kind of technique, and independent of the protocol, you must be able to verify if it's being used against you. Sometimes we cannot only rely on fixed signatures. We have several types of signatures, let's say standard ones based on opcodes, parameters, regular firewall, I would say. Then you have some heuristical ones, behavior-based. And also we have element profile. So when you look at it, you need ways to identify when something looks off. So also on TSG IDS, we have implemented element profile, which, let's say, observes the traffic coming from some elements. And it will tell you which elements have suspect behavior, which elements change function, change parameters. They are not behaving as a regular telecom element. This is the means to identify newer and fresher attacks, right? Something is off. It's not that I have detected some misuse or some prohibited message, but someone is tampering with your network. This is not HLR. This is not HSS. This is not P gateway. This is something else. It will be shown here. So when you have this kind of bypass, let's say on the firewall, but could be on the border as well, to have an IDS analyzing all this traffic, not only the blue, not only the yellow, because the blue and yellow firewall can see, but what's not sent to the firewall, or where firewall fails to block and considers blue, this report cannot feed you the good information. So you need to see the full requests and answers independent of protocol. It can be GTP, for instance, it can be diameter. You must see all the traffic going through, in and out, and you must identify threats independently on any of the layers. Afterwards, when you have the report, you can find issue is here, or issue was caused by a change on the configuration on the IPX. I'm not telling you call the IPX to revert the configuration. I'm telling you make your network more resilient, independent of the way they translate, the way they send the addressing, make those elements understand and block both ways, the old way, the new way. This is how we recommend you act on this subject. Again, let me take a look on the questions because some are very opportune to be answered. I'm saving the niche one for the end. How visible are these techniques? Thanks for the question. How can they be detected? What happens is that if you don't have any monitoring solution, they are not visible. You could do a security assessment, see if they are feasible, close some doors, but the security assessment will prove you that you're vulnerable, for instance, to XUDT is a scenario. And it will validate, and if you close the XUDT in that scenario, but maybe someone is tampering with XUDT and other technique and other parameters, so it's not possible to tell you no one is being successful at this moment. It's a way to increase, but the only way we see is monitoring. Monitoring has always a positive impact. So this is real mobile operator, real case study. In a matter of 4 months, we started with 200,000 attacks and attack attempts, and it went down to less than 20,000. How come? Because part of those were successful, and when we start monitoring and applying change to the rules, because this operator already had the firewall was there for over a year, but in this month, still 200,000 attempts and some thousands of successful attacks. Then when you close and you adjust the rules, the attackers just say, okay, I used to invest this amount of money and message and time because I had something in return, small number of success. Now I have 0. I will keep testing, trying. Maybe they will fall back. Maybe they will lose protection at some time. But I'm not investing all these efforts and money into attacking this operation. I'm not. When we started, 700 sources of attack were detected. After 5 months, less than 300 sources of attack. So this is the usual pattern we see when we implement monitoring. Other operators is a matter of weeks. So this is like a month in the life of the operator. It starts with some critical and then in a huge number of, let's say, attempts. Then we start closing doors, and the number of attempts increase, indeed. And at some point, it will start decreasing. So this is what first month view of a different operators, but still is 69% decrease on high severity attacks on the period. So this is like, it's every time is the same. You start closing doors, they use different bypass techniques, it increases efficiency, then you block these and you go down again, and then you exhaust attackers' capability to a point that this number of 300 data attack sources will become 10, 12, 5. It's just like keep alive. Just say, oh, for the sake of it, I will try to attack you from here from time to time, just to, let's say, maybe I get luck, maybe your protection has gone down, but that's it. That's what monitoring brings to the table. So this is what we brought today to present. Of course, I'll be addressing the questions now. Appreciate the questions sent. Let me just check some of them in full. Okay. Just you wait. See if I have a map of country attackers. Yes, not only I will show the origins, but you see the map and a heat map where you're being attacked from, and it can be filtered by time. So yes, you have let's say a real-time map of country attackers origins. Don't use these as, let's say, a means to blame some country. Use these as a means to protect yourself, because spoofing is possible. So I may try to attack you, and I may tell you I'm your next door operator. I'm on your country attacking you. This is just a spoofing addressing technique. I'm trying to, let's say, escape blame, repudiate. I'm not attacking you. This is your local MNO, your local competitor, but maybe don't call them the first time you see them on the map, okay? Because spoofing is possible on telecom networks, and you must study and, let's say, improve on defense. Afterwards, if you can prove, trace back, and this is really your neighbor, then you open a ticket to them. We have several operators that do that. They say, okay, I will implement the defense, but even so, I don't want this number of attacks to being repeatedly attempted against me. So I will also call the operator which is sending this. Another question, thank you. The segmentation attack, will it be detected as small format packets? And if it would be wise to block all small format packets? Oh, this makes my fingers itch, because security-wise, yes, but telco-wise, we build networks to make and connect people, to allow calls, allow traffic. So it's very hard when you talk about a situation when someone is abroad, out of the country, etc., and say, okay, let's block any more format packets. It's good as a target, but I wouldn't say put a rule and block it tomorrow. I would say instead, try to identify it, try to map it, put a detection rule on your monitoring, and contact your roaming partners. Have them to solve it, solve more format packets, solve wrong subsystem numbers, and all the real mistakes that happen on the network, okay? Then, when you have 1%, 0.01% of small format packets, you go there and you block it. And you say, okay, everything that happens afterwards will be, let's say, issue, failure. It's not, I'm not security is not impacting the service anymore. Just looking into other questions now. Okay. How monitoring would help on a SOC? Well, if you have a convergent SOC, monitoring would be a real source, the real source of data of this SOC. So we have some published use cases. You can look on our website, which is presented here. We have some operators that use our solution, integrate to their CM elements. It's easy integration. We have already the interface defined, available for integration. So just integrate with your CM. We transfer the knowledge on severity, on what to do in each case. And sometimes the CM itself creates a ticket. So the mobile operations team or the cybersecurity team can improve on firewall rules, or can improve on filtering somewhere. Or if not creating tickets automatically, we raise critical alarm on the SOC for every scenario which is not accepted by the operations. Let's say, oh, I don't accept message interception. Could be a second factor of authentication collection. I cannot tolerate that. So when one event of this nature shows up on IDS, you don't need someone looking at the screen. Your CM will get the alert, will process, and you put it on the SOC bigger screen. So that's how we are seeing some operators already structured and working that way. I don't know if you have any further questions on that. I would be more than happy to answer. I hope I have answered all the questions. I have answered all the ones that we were able to map. Maybe some questions are on LinkedIn and we'll sort them off later offline.
Yes, Gustavo, we tried to address a lot of them, but everyone on the call, thank you for joining us in this webinar and all your interesting and insightful questions. Given the time, we have tried to address, but this is not the end of it. We're going to, as promised, we're going to share a recording of this webinar. You have our direct access. You have the email ID of Gustavo Conte. You can write into him, or I'll be sharing with you the recorded webinar, and you can still post in and share your questions that you may have once you're going through the recorded version of it. So once again, a big thank you for joining us and making this discussion all the more interesting. And catch you soon again. We have a lineup of interesting and more webinars coming up in each month. So stay tuned for that. And take care.
Thank you, everyone.
Bye-bye. Thanks,
Bye.
Gustavo.
It's funny.